In this lesson we're going to discuss Lewis diagrams. Lewis diagrams are basically a simpler Bohr model, and they represent another way to show chemical bonding. Lewis diagrams, as I just mentioned, are a simpler version of Bohr diagrams in that they display only the valence electrons. Lewis diagrams are also called electron dot diagrams, in that we use dots to represent the electrons and place these dots around the element symbols at the top, bottom, left, and right side of the element symbol. We place electron dots singly until the fifth electron is reached or required, and then we pair them up. So let's look at some examples. So for the first example, we'll look at the halogen chlorine. So halogens are group 17, and they will have 7 valence electrons. So the steps are as follows. First one is to write down the element symbol. Chlorine, of course, has a symbol Cl. And then we're going to place dots around the element symbol first until we pair them up. So we can see that chlorine has 7 valence electrons, and you have to forgive my lack of artistic talent. So there's a Lewis diagram, or an electron dot diagram for chlorine. And we can see from that diagram that chlorine in fact does have space for one more electron, and it will actually pull that electron off other atoms very aggressively, which explains why it's so reactive. Now, magnesium is an alkaline earth metal. It belongs to group 2, and so the process here is as follows. Write the element symbol. Magnesium is just Mg, and it will have 2 valence electrons. So there's my electron dot diagram, or Lewis diagram, for magnesium. Now we can also use the Lewis diagrams to represent compounds. So for ionic compounds, what we do is remove 1 electron dot from the positive ion for each positive charge of the ion. So for example, sodium has a charge of positive 1, so a Lewis diagram for a sodium ion would have basically no electrons. And for negative ions, we add 1 electron dot to each valence shell for each negative charge of the ion. So for example, fluorine is group 17. It will have 7 valence electrons. The fluorine ion would have 8 valence electrons. As with Bohr diagrams, we use square brackets around the element symbol, and the charges are placed on the right side of the bracket. So for example, I was just talking about it, but a Bohr diagram, or sorry, Lewis diagram for a sodium ion would look like this, with a positive charge, and fluorine would look like this. So go around the outside shell, and fluorine will get an extra electron, so it would look like that. So there's Lewis diagrams for ions. Let's put it into practice for an ionic compound. Sodium oxide. So sodium oxide has the chemical formula Na2O, meaning there are 2 atoms of sodium for every atom of oxygen. Oxygen is a group 16 element, so therefore an atom of oxygen will have 6 valence electrons. So I'm just going to draw those around the outside of the symbol, and I'm just going to, for simplicity's sake, pair them up at the top and the bottom. So there is a Bohr diagram, or sorry, I keep saying Bohr diagram, Lewis diagram for an atom of oxygen. Now the formula is Na2O, so let's just draw sodium here on the right and the left side. So alkali metals will have 1 electron, at least their atoms will, and they transfer this 1 electron to oxygen. I just used a different color just to represent where that extra electron is coming from. So now I can use square brackets to represent the fact that these ions are charged. And so it's plus oxygen against 2 electrons. So it's going to be the oxide ion with a charge of -2. Let me make that a little bit neater. Yeah, still messy, but that's okay. And with the positive there. So we can see with the Lewis diagram, I said Lewis diagram this time, we have sodium oxide, and again these ions are held together by electrical charges. Let's talk about covalent bonds now. So Lewis diagrams are more commonly used for covalent bonds and covalent compounds. And in order to draw them, you need to know the molecular formula to draw a Lewis diagram for that molecule. And it's here we want to remember the octet rule, the idea that atoms want a full valence shell, and to do so they will gain or lose electrons. We can use a straight line to simplify our Lewis diagrams, and so we use a straight line for each bonding pair of electrons. Let's look at an example. So here I have ammonia. Ammonia is NH3, so in order to draw the Lewis diagram, what I want to do is write the symbols here. So I'm going to have nitrogen. Now nitrogen is in group 15, so it's going to have 5 valence electrons, and I'll just draw those here. So we got 1, 2, 3, 4, 5. Now I have ammonia. Of course, its chemical formula is NH3, so I can add my 3 hydrogens. Now in this compound here, ammonia is almost going to act like a alkali metal here essentially, but instead of transferring that one electron, they will share it. So here I'm just going to draw those 3 electrons here, and just to show that these are shared. I'm also going to talk about some vocabulary here. So and then I'll simplify this one up here in a sec, but we can see in this diagram here we have, it's called a bonding pair of electrons. So we have 3 bonding pairs of electrons in an ammonia molecule, and up at the top of the nitrogen atom we can also see another pair, and we just call that the lone pair. So these 2 electrons are not involved in bonding. And with all these dots here, it does get a little bit complicated. It's a little bit messy, so we can tidy this Bohr diagram, or Lewis diagram up. I gotta stop saying that. And so we can use the straight line to represent the 3 bonding pairs of electrons. And there is your Lewis diagram for ammonia, or of course nitrogen trihydride. So not every covalent bond, of course, forms a new compound. We did talk about the Brinkerhoff elements, so elements like fluorine. These guys exist as what are called diatomic molecules, and so we can look and actually see why fluorine exists as F2 by drawing a very simple Lewis diagram here. So fluorine is in group 17. So I'm going to start with 1 atom and see what I have here. So I have 7 valence electrons. I'm going to draw those out the outside shell. And so now we know, of course, the formula is F2. So I can draw 1, 2, 3, 4, 5, 6, 7. So there is a Lewis diagram for the diatomic molecule fluorine. And if I wanted to tidy up and use a straight line, I could do this and then draw the non-bonding pairs around the outside. And so this diagram again shows that what happens in fluorine is that each atom will share 1 electron, and we'll get a bond between the 2 atoms. So this is how to do Lewis structures. Hope this lesson helps you out, and